morning to everybody. This is the fourth tech talk of this session at PySchool. I'm Cristiano, the lead AI scientist here, and today I'm happy to welcome Simone, which is not only a tech talk speaker, but also a mentor for this session. Simone is an expert in AI in general, but with a focus on natural language processing, automated data analysis, and also human data augmentation. Is the founder and the managing director of Askdata, which is a startup that was recently acquired by SAP. They develop, let's say, an AI-driven platform that allows user to answer any data-related question, but with just a simple search. But I will then leave Simone to better describe what they are doing, what they are developing. In this talk, particularly, Simone will discuss about large language models and how they can be deployed to simplify many tasks in data analytics related to text and documents. So please, Simone, I will leave you the floor so you can reintroduce yourself maybe better than I did, and stop. So go ahead. Thank you.
Thank you, Cristiano, so much for the intro. No, the intro was super good, so thanks again. I'm super excited to be here for two reasons. First of all, because again, I'm also a mentor, so I try to support also some of you. And the second reason is because, I'm always happy to, contribute to the community of PySchool, since I was part of the community, as you will discover soon, for one particular reason. So I will share my screen with some deck. Just give me a feedback, basically, when you are able to see the screen.
Yeah, we can see the screen.
Okay, thanks so much. Fantastic. So I'm the founder at Askdata. Askdata is a company that has been founded in 2014. We had a huge team here in Rome, but also an extended team in the United States. We were backed by Y Combinator, that is an important tech investor. And also, I will say, P-Campus invested at Askdata just after the Y Combinator graduation. That's why I'm saying I'm, again, excited about being here. And what happened that within, I would say, the experience of creating Askdata and, doing this particular research about Askdata that is all about simplifying and making data experience frictionless, we were super, I would say, lucky, because we were able also to get in touch with a lot of interesting people in the data space, such as the chief product officer of Looker, now part of Google, Nick Caldwell, that invested in the company, and many other talented folks in the area. What happened last July? We got acquired by SAP. SAP is one of the largest software vendor that we have on the enterprise, at least, sector. And, we were acquired for a particular reason that we will learn, hopefully. So Askdata, as said, is, is a technology. It's an AI-driven technology that try to simplify this. And what is this? This is a dashboard. And dashboard, you have to think that is the most common way of consuming data. Right. So almost all the business organization, when they have to read some data, right, they use dashboards or tabular report like Excel. Those are two main consumption ways of consuming data. The problems about dashboards and let's say Excel reports is that at the end of the day, just a fraction of the users can easily consume this data. So, and usually data analysts or business analysts are super happy about consuming this data, this complex stuff. But then you have salesperson, marketing person that really struggle about consuming those data in a productive way. And Gartner, that is an analyst of that try to understand what's going on in the market, say and estimates that just less than 1/4, probably 10% of the users to whom those dashboards are really provided use them on a weekly or a daily basis. So what happens is that people get dashboards, but at the end of the day, they don't really use that every day. And the reason about this, let's say, low usage and adoption of dashboards is because it's like complex. So the experience is still terrible. And there are, at Askdata, first of all, before jumping on the technical side of it, we try to dissect and then trying to understand what were like the root cause behind this low usage of data tools like dashboards. And we identified the three main reasons. And the first one was skill gap. So not all the users, again, have the skills to understand like how measure and dimension works in a dashboard. The cognitive overload. So when you see a dashboard, your brain is overwhelmed about information. And fragmentation. Fragmentation is the fact that on one dashboard, you find some numbers or figures, and on another dashboard, you find other numbers, right? And your brain is really, again, puzzled about combining all this fragmented information across different screens. So skill gap, cognitive overload, data fragmentation. So at Askdata, we really needed to find like a solution about those three problems that were making, again, the usage of data analytics tool very low, as Gartner stated. And then I would say the idea was using artificial intelligence, and specifically we will see what kind of AI we're using in order to tackle this problem. And we have used specific different models in order to solve those three problems. For the skill gap, we invented a search-driven query, natural language querying system. So basically, you write sentence and you get answers just straight out of the data. And we will see with a live demo. With the cognitive overflow, in order to reduce basically these complex screens with a lot of dashboards and numbers, we invented from a user experience another way of consuming data that we call data card, that is super simple to use. And in this case, we use machine learning model in order to build this data card in a simple way. And the third one is about how to relate different information. So in order to solve the data fragmentation, and we use a semantic data graph that use, again, machine learning in order to easily join different sources of data for this, let's say, continuous experience across different data. So three different IPs that are part of the same platform that is called as the company, is named as the company, Askdata. So Askdata, we use artificial intelligence in order to simplify how human and data can basically work together in a frictionless way. How we do that? Let's start from the functionals. Again, not technical, but then don't worry, I will give also some technical details. But it's important, whatever you will learn about AI, is as important the technical part as important the functional part. So in order to have successful AI deployment, we have to solve a real business problem. That's why I'm really starting from the problems and then trying to share as much as possible lights on the problems. From a functional point of view, the problem that I already shared works a bit like this. So on the left, we have like a non-technical user. So the lady here, depicted here, is a non-technical person. So she doesn't know anything about data analytics, or she's not a business analyst, she's a saleswoman. And basically, she just wants to know, like the three countries that are performing better from a sales and profit basically perspective. So she doesn't know anything. She just writes a sentence. She press enter. Then this Askdata platform, that is a microservice platform that we will see, use different machine learning models in order to access different sources of data, retrieve the answer, build an easy-to-consume data card. That is this way of consuming data that I shared to you. And basically, the answer is provided to the end users. And all this, let's say, orchestration is done by, again, technology and machine learning models, but without overselling or sharing the fact that we use AI. So the experience is really like as simple as you would get like on Spotify or Netflix, on Google. So all the magics, let's say, happen behind the hood, under the hood, and what you get is this super simple experience. I don't know if there are any questions. Otherwise, I will do like a quick demo. And then I move to the practical part.
Simone, maybe I had a question for you. So it's already super interesting. I was wondering, well, maybe you cannot tell us, but you tell me. What kind of training data do you use to essentially convert from natural language questions to, actual queries that can be forwarded to Excel or any other database management system or things like that?
Absolutely. So first of all, so we have to. I will try to provide like a simple answer, but at the end of the day, there are like complex problems that needs to be solved contextually. So the first problem is that we work in the enterprise area. What does that mean? That having access and also sharing training data across different customers will be impossible, right? So that's the first problem that you have to really understand. And how we try to solve that, one of the sub-problems that we do is this anonymization, this online anonymization. So when somebody writes a sentence, one of the very important activity that we do, for instance, imagine that I want like the stock value of Goldman Sachs, right? Only the fact that I'm accessing to an information about Goldman Sachs is super sensitive, right? So we cannot share that information across different customers. So again, one sub-problem is that we need to anonymize all the, I would say, sensitive part. Like in this case, Goldman Sachs is an entity or stock value is a measure. In business intelligence, there are like 3 different types of entities. So one is, again, like the business entity, like Goldman Sachs. One is the measure. Measures are like the numbers, like profits and loss or whatever. And there is another one that is the dimension. The dimension is the dimensional analysis across you can do analysis, like make an example, all the different stocks, all the different markets to where these stocks belongs. So basically, every time that somebody shoots a sentence, we do an anonymization first. Second, we use this anonymized version of the sentence in order to translate that in a query. But this query is not specific for a particular dialect. So it's not for Excel, it's not for MySQL, it's not for Oracle, but it's abstract. And then we use another model to translate basically this abstract query, anonymized query, in a dialect-specific query. And then we can finally perform like the query, get the results, and then we use another machine learning model in order to build the output. So that's, I try to simplify, but you will see with some process. So the message here is that in order to have like a nice user experience, at the end of the day, you have to orchestrate across different models, and all this complexity has to be done basically under the hood. That's like the first message that I want to share. So just to provide like again a simplified version of this, right? So limited identity recognition and anonymization, query prediction, dataset selection, and result representation are the 4 steps that basically I shared before are performed contextually, or at least the first 3, and then the results representation, of course, after that the query has been run, I have some results. So the model that performed the result representation is important because basically for a result set we could use to show the results with a table or with a chart, right? So the layout of the data card is driven by this 4th, basically, machine learning model. 2 types of problems we are tackling with AI: query understanding, but also data understanding, right? Because those have to basically match. I will stop for another second. I don't know if I've been clear.
Yeah, thank you very much.
Okay, so let's see. I would say, again, on the product side, what happens. Don't worry, I cannot, of course, say too much, so everything about the process, but don't worry, I will tell you a bit even more. So just to remove some noise. But the important is super pragmatic. So we have machine learning models, we have like a platform that orchestrates all the access, and I can provide some additional details also about the data sets that we use at the end, and some strategies. Okay, so let's start with with like with a demo. So let's take, okay, this is a tenant. So the first concept about the platform is that it's a multi-tenant platform. This is like an IT concept. It's not a machine learning concept. Multi-tenant means that basically I have like a segregation of different customers served by the same platform. And this segregation, so the data of one customer are separated by the data of other customers. And this is by design. In this case, I'm opening, let's say, the data of one particular customers. And these customers, let's say it's called the sales demo. That's basically a demo, let's tenant again, where I have connected in the dataset section to MySQL data warehouse. But eventually I can add other stuff from Oracle and other kinds of technology, SAP HANA, and so on and so forth. And the experience, as you will see, really look like basically a social network here. And I can just write a sentence here, and this is like the bar that I have on top. In this case, my sentence was super simple, so I just wrote sales, and then the system used again the machine learning models that I described in order to generate this data card. Of course, I can say, I don't know, top 3 countries by sales. So I'm just making like the query a bit more complex. In this case, I'm asking for the top 3 countries for a particular measure. And as you will see, the experience is always like the same, right? But so this brutal simplicity just lead to what? To a simple content that is crafted in a way that is easy to consume for the end user. Let me provide some additional information. As shared is really like Netflix or Spotify. Why? Because under the hood, I'm not just doing like a straight translation, but the fact that we use machine learning models let us to also inherit a lot of things that people really like about data and consuming data. In this case, for instance, I've already created a card that, since the information, the data points are limited, the best way is to display them with a table. But this table is already sorted, as you can see, in a way that put like the country with the most sales on top and the country with the least sales below. And I get like a visual feed where I say, hey, this is the interpretation that I got, right? So those are like the columns, let's say, on the database that I selected, store country and store sales. On the measure, I apply this aggregation that is a sum, because you have to think that the data set below is not like basically composed of 3 records, right? So basically it's like a data warehouse of products. So here we are doing like a group by, so we are doing an aggregation of the measure sum on a particular dimension, and this is like the output. So again, brutal simplicity, but then all those things are done under the hood. I get the card, and with the, I would say, the easiest of the experience, I can, just take this content and share that to somebody else. In this case, I've shared that to Maria Luisa, that with an internal messaging system just got like the card. Okay. Look here. Okay. So you see, it's really like an Instagram experience, but this is happening basically on top of data and not happening basically on top of I don't know, pics of Gucci jewelry stuff. I will just stop again just to get some question, if any. No questions?
So I think one of our
maybe there is one in the chat.
Yeah, he was presenting you with a challenge already.
Sure.
Basically, it asks you to retrieve the top 3 countries by sales without Mexico, given that we know that Mexico is one of the top 3.
Absolutely. So just 1 second, let me share again. The screen. Okay, so I would say, let's say sales by countries. Okay. In this case, sales by countries. I'm just sharing like all the countries and the, for one particular, let's say, for the data sets. Okay, now I have another session here. Okay. Sales by countries. Okay, so now I just want to share that basically the countries are 3, just to avoid. That's why I've asked the sales by countries. Okay, so let's say top country by sales. Okay, I will show you all the thing. No? In this case, so I'm just asking like USA, right? Because that was like the first element, excluding, let's say, United States. So I'm doing the same thing, but from below, basically, right? Okay, in this case, is Mexico, okay? So as you can see, the feedback say, because now I get Mexico because it was like the second one. So I've done the same thing in a bit more complex way to show you that we are shifting like the first one from. I don't know if that's clear.
I would say success.
Exactly.
Right,
now let's try even more difficult. To expect Canada, in fact. You see?
Yeah, awesome.
Clear? So now you believe there is machine learning behind. It's not somebody. Yeah. Okay. No. I would say it's super cool because really let non-technical people to, I would say, simply explore data. That is exactly what we, as a P school, we should tackle. So augment people, right? It's one of the slogan of the school with machine learning. So machine learning, not for the sake of doing machine learning, but just to augment how people can do their job in a much more, let's say, efficient way or a particular way. Any question?
I have one question.
Sure.
So basically, we are making the query in our language, like normal English language, and it's getting converted to an intermediate form, like a SQL language. Is it the case?
Yeah, I just missed, but for my fault, the question. So is the case, but what is the question? But my fault that I missed it.
Oh, so the natural language query is converted to an SQL language.
Correct. No, it's correct. The only thing is that it's not done in just one iteration, but it's super important. And that's what I shared basically with the slide with the 3, let's say, circle plus the additional circle that is done using different models contextually. So it's not something that is done just translating, because there are some, and this is like the innovation of Askdata. There are many different like text to SQL models, but it's almost impossible. This is my experience of 8 years of working, to do everything just with one model. Why? Because basically every single database has a different dialect, every single data set has a different structure. So you cannot do, at least with what you have today. I'm not saying that, of course, with AGI, whatever. It's not possible. Also preserving like the data privacy thing that I was saying, to do everything. So the innovation is that we use more models, exactly as Google or the service of Spotify or Netflix. So we have to think it's not just one model, but it's an orchestration of models that then at the end of the day build the results, right? It's like a system. This is another important thing, a message to the school. Sometimes when you see something that works in a smart way, it's not one model, like Alexa, right? It's not one model, it's like tons of models orchestrated as a system. I don't know if you are confused about my answer.
Yeah, it's clear. So basically, like if like different databases would have different schemas and different models for those schemas.
Absolutely, and no, I would say it's for different problems. Now I will share with you the names of the models. Probably from the names of the models will be easier. So all the models that we use. Just 1 second. Okay, so I would say all the models that we use are transform basically architectures. So I think you're familiar with the transformers, right? So I don't have to explain too much. Like these neural network architecture with self-attention. I expect that everyone more or less is familiar with this. We use different like types of transformers in order to solve different problems. So I would say there are like three families of transformers, like encoding only, like BERT, decoding only, like GPT, GPTX, or whatever, or encoding and decoding that are able, basically as an input and output, to do basically like for instance translations, right? So you get an embedding and you get also like an encoding and you get like a decoding. At Askdata, basically we have built those models. For instance, NL2 query is a natural language query. So it's the first of the model that I mentioned before. So the model that from anonymized text can generate what an anonymized request. But this request is not pure SQL, but it's like an abstract SQL. Then we have another machine learning model that from the query, so the technical query that is not a specific SQL dialect, get as an input the query plus the dialect, and is able to translate a query that is for a specific dialect, like MySQL or Oracle, right? So another, for instance, model that we have built is called complex field. So basically, from a natural language request, I can, do like complex field expression, like ratios or percentage, everything in line. And other models let me to do the join. So it's dedicated just to understand what's the best way of joining two different data sets or table, let's say, in real time. Another model is NLG. So we are basically able, from a result set, to build like a sentence in natural language. Another model is able to augment synonyms from one synonym to different synonyms. Another one is Martner, that does the anonymization that I was mentioning before. And another is AutoInsight, that is able from one request of predicting what are like other questions that are interested in as a follow-up. So this model is used to do automated analysis. So for instance, you can start from a question and get suggestion on additional other questions from there. And this is like a description of the different models that we have built. But basically, again, the thing that I want to share with you is that it's not one model. It's like, in order to build AI systems or AI-driven systems, sometimes it's a combination of models, and you have to really understand. All these models were leverage like this breakthrough of the transformer architecture. So we have to think that more or less we have done the same thing since 2014, also when transformers were not there. But the performance that we were able to achieve was, I would say, incredibly higher. So we have started with TensorFlow sec to sec, but the performance was like not like today. So we had to do a lot of let's say, engineering things to make it working at the beginning. But now, thanks to this, let's say, breakthrough, we were able to have this consistent pipeline. This super important to train a machine learning model. Can you show how to train foundation model, how to reproduce? So there are two questions. So I will stop for a second to answer the two questions. So first is from Serdar Altan. So companies have different business and so different models. So how do you get sufficient data to train and predict and retrain a data set for a particular company? Okay. Are you tight? Brace yourself, as they say at the airplane. It's the very same machine learning models for all the customer. So the magic is we don't use or retrain the models for the customer. So we don't use fine-tune for different customers. Is the very same models. How we can achieve that? We can achieve that, again, as a combination of things. Why? Because basically the NL2 query model that we built is based already on anonymized request. So basically we use a prediction that is able to anonymize, use basically the sentence plus a knowledge graph as an input and generate a query, but without using the data of the customer. Don't worry. What does that mean? So the message here is that we don't use one model or retrain one model per customer. It's the same for all the customers. And the model, the NL2 query, has been trained in a way that can make automatically the prediction. Why? Because we don't use as an input of the model only the sentence, but we use the sentence plus a knowledge graph. And the knowledge graph is like a dictionary of the columns, basically, that I have for that particular customers. I show you a chart, and then probably it will be a bit easier, but feel free to ask additional things. So about that. Just 1 second, I take like the chart. Okay, so this is like the, so basically this is not, so I will just say this is like the let's say this is the abstract query, and this is the client specific query, let's say. I'm just trying to simplify a bit. Okay, so now this is the sentence. So give me revenue by regions, make an example, right? This is the input to the human to query, but this model does not take only this input. The other input that it takes is the knowledge graph. So the knowledge graph is just like the list of all the columns available for a particular customers. And this is like a live input. So it's not part of the training, it's like an input. So basically the model, so the language model, just get, again, the sentence plus the list of columns for that particular customers, available customers. Of course, we reduce a bit this list to be sure, because otherwise the language model has a limited length, right, as an input. So I would say, a curated, or we use the other model that is NER, Smart NER, to reduce the knowledge graph. Otherwise, the knowledge graph sites for enterprise customers would be too much, the length would be too much high, right? So we reduce, so I would say a subset of the knowledge graph plus the sentence as an input of the human to query, and basically this let us to generate an abstract query. This abstract query is sent to another model that is the query to SQL, that generates the real SQL, I will say, that then can be executed to the dataset. In this case, to the different datasets. And the query to SQL as an input has the abstract query plus some knowledge graph plus the name of the dialect. The dialect can be MySQL, Oracle, and so on and so forth. I will stop for a second. But the cool part of this is that we don't train one model for customer, but it's the very same model. And this is very beneficial. Why? Because we can keep adding like new models and deploying new models to customers that as a series, they get better, basically, performance over the time. So it's very scalable. Because basically the knowledge graph is what is local to the customer, while the model, right, gets new version. And what we do, for instance, we extend new languages, or we extend new capabilities, right, like join or transformation, people excluding, for instance, this kind of stuff. So there was another question. I don't know, it's clear, I would say, the message, the fact that we don't retrain for a customer, everything is hot, okay. Please, can you throw light on how to train foundation model, how to reproduce, implement such model? Yeah, sure. I would say the good thing about foundation model is that they are abundant, they are free, most of them. They are free, abundant, good licensing. So you don't have to reinvent the wheel, especially if you are not part of OpenAI and this kind of company. Why? Because, of course, to train from scratch a model is very expensive, right? We decided by design to do not rely on foundation model, let's say, under the curtain, like a GPT-3, for instance. Why? Because we wanted to have like control of the data, right? We cannot send data to an API. So we are using, let's say, foundation models, of course, where we can have like the end-to-end control that are basically with some licenses that we are familiar, or let's say that we can use commercially, because another important thing, if you want to use those models, you have to know if the data sets and the models themselves, so the data sets used for the pre-training and the models itself can be used commercially. For instance, with the language models released by Facebook, for instance, the OPT family, you cannot use them for some commercial reason, but just for basically academic research, right? So first of all is language foundation models are abundant. Find the one that is compatible with your business requirement. Once you find it, the real thing is that more or less the performance is good, but you need data, right? So the complex part of it is building your proprietary data set, especially if you want to build like a competitive edge. In our case, we have built proprietary data sets for every single of the models that I've showed you. How do we create proprietary data sets? Because everyone say, hey, but it's difficult to collect proprietary data. We use generative model, and we invest a lot of money also and time and resources to generate automatically. So we use AI to build across different domains, balanced domains, all the different combinations of data structures that can be coherent with our sentences. We build balanced, let's say, models that then can be deployed. Then we deploy those models to real customers, and we try, of course, to fix things if we break something. But the value is on the data set. I will say, of course, we have invested time in doing some, let's say, training or fine-tuning scripts, but most of the work is about the data sets. That's the message. Another important thing, it's called the Chinchilla Insight. So basically, there is a paper from DeepMind that is shed a light to the fact that the data sets usually, most of the language models usually are undertrained. So basically, again, you need good training, high quality training. That's the thing. So they can, in this paper, it's called Chinchilla. I don't know if you went through the P school or Pi school or they shared that with you already. But basically, the insight from this paper is that it's not about always sites, like hyperparameter sites, but it's also most of the game about quality. That's why OpenAI, one of the latest statements that they shared is they don't think that the next generation of GPTX, I mean GPT number, right? So 4 or 5 or whatever, because there is also a model that is called GPTX. I don't want to confuse you. Will basically, they don't expect a larger number of hyperparameters, but more like a work on the data sets and the data set quality. What if these are badly constructed database, field names does not make sense? Okay. Good question. Basically, we use an asynchronous machine learning model again to clean the business names from the columns. And then, so I make an example. Imagine that I have like sales underscore count, like an example, right? So we have like a machine learning models that import and create the knowledge graph. And then the knowledge graph is saved to a database. We use Elastic. And then you can like correct the names, of course, if the machine learning models didn't have done like a good job of deriving like the correct business name from the field of the columns. That was from Menan Velayutan. I don't know if I answered to your question. So it's asynchronous. So we read the data source, we build the knowledge graph. The user can refine the output, and then you have like a clean knowledge graph that can be used for the second iteration. Okay. Grazie, Cristiano. Thanks, Cristiano. For that's a very nice. So Cristiano has published on the message chat like the reference to the paper I was basically referring to. Okay, so that's like I don't know if you have any other question. Otherwise, I will keep. I will keep speaking. Okay.
I have a question. If no, maybe somebody was talking. No, I have a question. Just a curiosity.
Yes,
what's your view for the next 5 years in natural language processing? What will be the next step? For instance, now we are embedding documents. They are starting embedding. I don't know, maybe concepts. What in general your view in what do you think will be in 5 years, or maybe just 3 years?
yeah, I would say also guessing 1 year, as you know, it's Yeah, and this is my definition of intelligence. My definition of intelligence is predicting. So now you're asking to predict. So I don't know if I'm intelligent enough to answer, but I will try. No, my view is that basically we have a lot.
Neither I. I'm asking just because I'm not intelligent. So I'm not intelligent to predict. So, but I can ask. So at least
collective intelligence. That's another area, right? Collective intelligence. No. So the thing is that my view is that we have a lot of work to do on the industry side. So I think that academia and research are like already shed on the shelf a lot of interesting things, but then the industry, and in the industry, like software houses and these kind of things, has to like step up already with these, let's say, papers and information that we have, again, to build like AI systems, right? But the thing is that, so from one end, I see that the software industry is embracing, of course, machine learning, but we can do more. So I expect, I would say Italian companies or whatever. So machine learning everywhere, right? That's how I hope, more than I predict, that we have to accelerate, again, from the adoption of this kind of thing. On the other hand, what I see for the foreseeable future is these, let's say, open collaboration projects, finally, on the machine learning. For instance, I think that you are aware about, this stable diffusion, for instance, initiatives, and so in this case for the text to image. So I really hope that finally, after this first wave of, let's say, huge research company like OpenAI, that has opened just the name, we really see some, let's say, open models, open weights, and all. Because now what happens? The research companies, basically, they produce the research, and then we have like 2-3 years delay about reproducing like the results from the research, right? And what happened is basically with this stable diffusion thing, we were able to accelerate also the benefits of the value with the release of very good data sets. So you have to think, for instance, on the images we got from a collective called Lion AI, again linked to Stability AI, those new data sets, new encoding models, like, for instance, the new WIP, new clip, and so on and so forth. And now we have seen the benefit. So we have to think that in 2-3 months, we went from the text-to-image generation that was able to run on laptops to text-to-videos that were able to generate not on laptops, but on, let's say, commodity hardware. So it's this is really, I would say, like more like how I expect and I hope to see, like an open, collaborative, for real, distributed work. But there are some bottlenecks. For instance, of course, the hardware. So probably the bottlenecks. So the elephant in the room is that we cannot rely on this only centralized way of training models, but we should find a way of training in a distributed way models. Sorry for my long answer, but it's of course exciting as a question. That's why
Thank you. I know it's not an easy question, but I was curious about your view.
Absolutely. Okay. So we have a question. Either.
Yeah. Hi. Thanks for the talk. It was really nice. As I wanted to ask you, since you're running an AI company, especially with a lot of large language models that come out, there's like new models almost every week. So how do you keep up with this, especially as an industry? Is there, like you said earlier, there's a delay, between the model being in a research paper and then being, deployed in production. But now that with, things like stable diffusion, that's kind of that gap has reduced and more startups are coming into the space. How do you manage to keep up with all of this?
Absolutely. That's a very good question. So how I manage, so basically I have like my influencer, so I follow them like on Twitter, and this is important, the role of this influencer. Why? Because they do some curation, right? So they try to limit like this overwhelming thing. And there are also companies that I like follow, like Hugging Face, that can let you try in a tangible way, and then you can understand if that is related to what you want to do. So I would say the suggestion that I share with everyone is like to find their own mission. So you cannot just do AI, right? It's too broad. It's too confusing, and also emotionally can be. You can get this thing of FOMO, it's called in the US, so fear of missing out, right? So I'm missing something cool. So you should find like your thing. So you are, for instance, in my case, it was a relief again. We went from like a broad AI company when we started in 2014 to this data narrowed company. So again, now I just try to follow and pick the things that are in my area. But this is a positive. Why? Because in Silicon Valley, Y Combinator, they tell you that the more you can be an expert, right, the more valuable you are, right? And with all this, so my thing is that try to find something that when you wake up in the morning really ignites you of enthusiasm. And the answer should not be everything. Otherwise, it's very difficult to, I will say again, to keep faith. So reduce the narrow. I'm pretty sure that you will have some interest, right, in something like robotics or whatever, right? Narrow and be an expert there. It tests you impact. First, you reduce the FOMO, and then you can follow just the things. Plus, the trick is to follow influencers that are real influencers, or companies that are really, let's say, market maker. Like, of course, there are a few folks on OpenAI, a few folks at, of course, Yan Kun, LeCun, whatever, right? So there are like few people that at least when they speak, you get some content, and you don't just get the noise. So that's an important thing. Reduce the noise.
Thank you. Just to add my 2 cents. Yeah, I find very difficult to focus just on one topic. I'm obviously not the only one, because you see, people interested into science and technology, they are by default curious people, and curious people are find really a lot of difficulties in just focusing on one topic, because curiosity, it's all about trying to understand maybe more than one thing, or maybe try to better understand new things. So I really find very difficult to focus on just one topic. And in addition, a lot of people into technology like us have different background. I have a background in theoretical physics, but and I was doing particle physics, then quantum information. So I'm still curious about particle physics, quantum information, and now some topics in machine learning. So it's really a mess in my case, because I spend a lot of time reading also all the stuff that I was interested in, try to follow in the new research topics in quantum information theory, but at the same time trying to understanding diffusion models.
You are doubling down if you go there. No,
it's crazy. It's great. I'm getting crazy. I'm really getting crazy. But so I very find my dream is just to be interested in one thing, but it's not easy. On the second point, sorry.
Try the message that I really want to. So when we were doing but of course, Cristiano, you have to be a bit more broad. But for the other teams and the alumni, I say, if you focus, you can become like a word expert, and that's why SAP acquired basically Askdata. Not because we were like an AI company, right? But we were like an expert in that particular field.
Yeah.
And it's a bit more motivational, of course, also for you, because then you every single day, right? You do like another step, right? You get a bit of, because otherwise, if imagine the same company, but that we want to do everything, right? Language vision or whatever, right? At the end of the day. So my suggestion again is that I do some AI art also, but as a not as professional. I don't know if you guys. So
okay. Yes.
So
yeah, that's the truth. No, that's a very good suggestion. So if you found something, it must be very vertical, but then. So as a founder, as an entrepreneur, or as a scientist into your company, you must focus on just one topic and go through that one very deep. But at the same time, you as a person, in your free time or whenever, you can explore new subjects. Okay. Perfect.
I just had another follow-up question. Do you know what I asked? Thanks, Cristiano, for that. You know, and this, especially in this time, you're building up a lot of, especially transformer models. You're usually using an already built up implementation, and you're fine tuning it. So how do you think your role as, you know, as someone who's doing a developer, a machine learning engineer, has changed, you know, from when you started, say 14, 16 to 2022? Is it changed a lot? Like you have to write drastically less code? And do you like the fact that you have perhaps less control over your code as opposed to when you started?
No, I have more control. I have more control because I can focus on things that are really meaningful, like build balanced data sets or build applications. You know, really like with the pre-trained models, you stand on the shoulder of the giants. Is that exactly like, imagine that you are like a designer, right? You want to design. You don't want to build like Photoshop before design, right? Because you are a designer. And basically, we want to build like AI-driven stuff, right? So the fact that we can start from pre-trained model, it's like a dream, because again, instead of building the model from scratch, as we were doing at the beginning, we can start already with something. So that's really like another interpretation. My role became way much more interesting. And imagine that it's called also composable business. I make an example on a different way, not as a designer. Imagine that you want to open a shop, right? Today, or in, I don't know, in the mid-centuries. Today, you know, you can order things on Amazon, you get something. Then you can design your logos. So now I would say the time to market for your ideas is shorter, right? Imagine, I don't know, 100 years ago, also sourcing like the ingredients or whatever to open a shop or the raw material. So this is the thing, so the change that I wanna share. Now our job as a AI enthusiast is we don't have to start from scratch. Imagine also people, again, in the software that like apps developer, right? So usually today they use SDK, and building an app with the SDK is super fast. Imagine building an app before that, right? Or with a graphical model, again, 3D Unity or those kind of 3D engines. Now let us 3D fund people to build software in a place. So go to ideas, I would say. No, go to market. Go to ideas is shortened, and the impact that you can do is where. But then you can always build from scratch or retrain from scratch a model, but as a side job or a side thing, as I was saying. So you start. So I'm super happy. So I really want to thank you all. I don't know if there are other questions, because it's super exciting to share at least our experience. Okay, so if there are no other questions, I just invest the last 60 seconds to share what's next. So we are doing. Basically, we are, now that we have all these models and the stuff, we're trying to build like another language model as a wrapper for all these models, like a real super data assistant. And that's basically what is building. So the idea is to have like a language model as a gateway to access all the different language models. That's the big thing that we have on the table. So we have something that simplify basically the interaction with the models, reducing the work done by the basically platform. So less software, basically a layer of intelligence that is not microservice defined by Java, but basically it's AI driven. And so happy to say that, of course, we are, I'm in connections. So whatever other questions or mentorship or requests do you have, I'm super happy to join and provide info.
So thank you very much. Were really interesting. Also the question, your answer, and for everybody, feel free to write to Simone if you have any curiosity. And thank you again to everybody, and hope to see you soon.
Bye bye.
Bye bye.
Thanks, Simone.
Bye.
Thank
Thank you.
Grazie Simone.